number of years ago, we had some discussion at the Artisan Center about adding some workshop type classes, and one of the things that I thought might be fun to do was to turn spheres. I'd done a few spheres, but had to do some research on them, and I did all the research and stuff and found a whole bunch of different techniques for doing them, and then we published the class in the catalog, and nobody ever signed up for it. So you guys are um, there are a number of different methods for doing spheres, and some of them have some pretty complicated math. Some of them use jigs, and so I decided, that pretty early on that I thought, a jig would be the way to go, because I kind of like jigs and stuff like that anyway. So I bought an inexpensive jig, an English jig, which happens to be the one that chefware kits first started selling in this country about 8 or 10 years ago. And when I got it, I started setting it up, tried to use it, and I discovered, straight away that the jig is probably not really the way to go unless you're going to do a lot of spheres that are absolutely identical. And it comes in real handy for doing things like resins. I've done a number of spheres with resins, and the jig is the way to go there because it does have control over the position of the cutting surface. And my jig uses a negative rake carbide cutter, and so it works pretty well for that. But the problem with the jig is that the jig is difficult to set up, and it's not really repeatable. So if you set it up one time, and unless you have everything perfectly positioned on the lathe, your chuck is exactly the same. You have to go through a setup procedure, and if you miss on it a little bit, you wind up not with a sphere, but you wind up with an egg or a football. And that's not the way to go. So I started looking at other methods, and one that I came up with was one called the octagon method, and did this chart, and it works pretty well, but the problem is it involves quite a bit of math. And, I was never that good at math anyway, but when I'm trying to multiply the diameter of a cylinder like this times 0.293 and calculate that in fractions, it doesn't work very well. And then it dawned on me that 0.293 is awful close to 0.30, which is 30%. So instead of measuring this stuff in the imperial system or even the decimal system, if I start doing this in metric, I'm home free. Because if this cylinder, and I haven't measured this one, but if this cylinder was 40 millimeters in diameter, it's pretty easy for me to calculate 30% of 40 millimeters. It's 12 millimeters. And the reason is that when you're constructing these things, according to even to this methodology, all you're doing is constructing a series of cutting surfaces or cutting marks that are tangential angles. And if you measure in 30% here, and then 40% and 30%, you've got 100%, which is also the diameter of the sphere. And that kind of made sense. Still, there was a little bit of math involved. And then as I poked around, I found a guy in New Zealand named Soren Berger. And Soren Berger came up with a much easier way to do this. He invented a caliper that does all of the measurements for you. You don't have to do any measurement at all. So, that's the name of the game that I want to play. And what Soren's caliper does is you measure the diameter of your cylinder, and after that, you don't touch the position of the caliper sphere. You have the big angle, what he calls the beak, and the ears. It does look kind of like a bird. And the beak represents about 30%, or 0.293 actually. And then the ears measure that same percentage of what you're going to, of the space that you're going to be cutting off here. So to use his method, not used to this lathe, and lock her down. First of all, I'm going to do just about a 3/8 of an inch deep cut here, just to define where the end is. Okay. So I put a mark here. A mark here. And a mark here. So I've got 30%, 40%, and 30%, roughly. I like the way this thing chirps at you. Okay. Oh. Now what I'm doing here is I'm taking the tenon down to the same diameter as the center portion, the 40%. Oh, and by the way, if you're doing this, little safety tip, I guess, and you're using the inexpensive calipers that a lot of us pick up from places like Harbor Freight and so forth, make sure you round off the tips of these, because they do come, in most cases, they come pretty sharp. And if you don't round the tip of them off, you can get a really nasty catch that does really nasty things with your fingers. These are rounded off, so I'm fairly comfortable using them. Yeah. Well, no, actually, 40. Yeah. So the center's 40. This is 40. And ironically, by doing that, the distance from the tenon to the edge is the same as the 30% on top. So I've got 30, 30, 40, 30, and then 30 over here. I need to give myself a little bit of space to work here. I'm going to put a black mark right here and another one over here. The object of that is so that I have a target to go to. I'm going to start from the edge here, and I'm going to do nothing but straight cuts down to the black mark in the center. Okay, so now we've got what was represented as the octagon. We have a total of 8, or I guess this is actually 6 sides. We'll wind up with 8 when we go to the next step. And one of the things I like about these calipers is if I mess them up, all I have to do is go back and remeasure the diameter at the center, and I've got do a red mark there. Well, there's got to be some ink in there somewhere. There we go. Okay, what I'm going to do now is I'm going to essentially take off the space between the red lines. Mark the waist area. And at this point I'm doing nothing but straight cuts. Not doing any angle cuts. I'm not trying to form it into a sphere or anything. I'm just trying to do straight cuts to get rid of the material. And I'm intentionally leaving the red lines. I'm not cutting the red lines away. There's a reason for that. Okay, now between the red lines, I'm just going to eyeball and do about halfway between each one. And now we make the red lines disappear. And at this point, I am doing a little bit of a shaping cut, not very much, by turning my wrist while I turn. Yeah, yeah. The object is to get rid of the red lines and leave some of the black. Yeah, we're getting pretty close there. And if I want to do a little bit of shaping now with, I'm using a negative rake scraper. And the object here is not to get it perfectly smooth, but to just get it close. Hey, we had at the symposium in St. Paul, we had a guy that was going around to some of the exhibits and happened to be staying in the same hotel I was in, and he walked up to Ron Odegaard from Appleton and asked us if we wanted a sample of his sanding product. And he gave us a little box like this that has, some sanding samples in it. It's called Grit Grip. And what it is two-sided sanding paper that is actually pretty heavy. It's almost like a cardboard or rubberized material. And I wouldn't advocate using it on anything that you're going to put a real fine finish on, but to break down a piece like this and get a rough sanding job on it, it actually works pretty well. The coarser grits of it will leave scratches that you cannot get out. But if you start sanding with like the 120 grit, you can actually take off quite a bit of your tool mark and some of the other debris that you might leave behind. And it goes pretty fast. I think this is 120 that I'm using now. The one problem that I had with it, and that I think some other people did too, is it's laser engraved. Oh, this is 180. But the problem is you can't see the laser markings on it until after you started sanding with it. So they got something backwards there. Wouldn't you want to know the grit before you started sanding? We'll see what grit this one is. Okay, that's about enough. So now we've got kind of a rough sphere that's got the nubs on both ends, but the shape isn't too bad. It doesn't look like. I could turn this off, but since I'm turning between centers, I can't go all the way anyway, and I notice I didn't bring a thin parting tool, so we'll just use a saw. Now, somebody asked earlier if I had bought a set of cups from, there are a number of companies that manufacture cups for this purpose to put on both the spindle and the live center. No, I've never actually bought a set of cups. It's probably one of the few things that I haven't bought is to do this. There are two ways to approach this. If I would have made my blank a little bit longer so that I had a little bit more material here at the end and put a tenon on it, I would actually be able to turn the cup out of the waste material. I've done that quite often with these, and the waste material cups actually work pretty well. Just pass that around. And I brought along a couple of pieces that show the a sphere in progress. So you can take those and but cups are easy to make. So I brought along one of my homemade cups today. And this one is somewhere I picked up a deal on, and I'm not sure what they were for, but these are threaded to the proper thread, proper diameter, and they have a recess back. They're about an inch deep, and I think I bought them, from someplace online years ago. I've still got a few of them left. I embed these into a block of maple and epoxy them in, so I can just screw it on. Otherwise, using a block like the one I just showed you here, works just as well. What was all that noise over there? Okay. Oh, I missed that. Yeah. This is a real expensive jig. They come, I think they were $1.29 at Menards for 4 of them. And the one thing you do want to do is don't just put the stopper on your live center and expect it not to do some damage to your piece, because the point on your live center will poke through the bottom of the rubber. Well, how do you deal with that? Well, this is where another expense comes in. You have to go to the hardware aisle and get some washers. And it just happens that a 1/4 inch washer happens to fit perfectly into the 3/4 inch chair leg. And now it won't poke through. It gives me a nice solid surface here, and yet it's got enough flexibility that it holds on to the sphere. I, I never could understand why people thought it was such a big issue to do a really fancy cup for the live center, because all it's doing is applying pressure back to whatever you put on the headstock side. So these make a lot of sense, and frankly, if I lose these, I don't care. If a student, I do a wood turning, a segment of wood turning class where we do some use of this at the Artisan Center. The student takes off with one of them, I don't care. Like I say, I go buy them in a package of 4 for under $1.50. It's okay. So, we'll take the negative rake scraper and very carefully take those nubs off. And what I'm doing here is I'm not watching the tool, I'm looking at the profile up here. And with that floor, it's a little bit hard to see. If I had a darker floor or something dark down below, it'd be a lot easier to see. And one thing that is easy to do when you're like taking the nubs off or doing your final shaping, it's easy to get too aggressive. And if you get too aggressive, all of a sudden you wind up having to do a whole lot of turns where you're flipping this and changing angles in it. So, this is one of those cases where, really thin, light cuts are actually the way to go. And I've got a little bit of a hump here I have to get rid of. And by the way, this is a round nose negative rake scraper that I'm using. I've seen some guys do this with a gouge, with a spindle gouge. Could do it that way, but I just have more luck, I think, with a scraper. And what some people do is they'll leave before they part it off, they'll put a center line in, and that way the center line will give them some reference as they rotate this. But the problem that I've had with that is that the center line goes away pretty fast anyway, so I haven't seen it necessary to do that, but that is a trick that some people use. And I'm just rotating it around now. You know, I do feel that I've got a few rough spots in it, and if I wanted to take, you know, more time with it, I could probably get it smoothed out so that it's pretty well round. A lot of people say that you make these perfectly round. I'm not sure that you can ever really turn a perfectly round sphere, because we're dealing with a natural product here that moves anyway. And obviously, you want to do kiln dried or really dry wood. Oh, this lathe doesn't do that, huh? Tried to go down to 0 with uh, the, the speed. No, it won't. No. It thinks 140 is as slow as I need to go. Yeah, it rolls and it didn't jump too much, so must be good. Any questions?
So,
Yeah,
I got questions.
yeah.
I don't have those calipers.
You don't need them. All you need, just right here,
Okay.
and use the metric system. Because if you measure everything in millimeters, you know, the metric system is done on a base of 10. So the math is really simple.
So
And if you,
start out with a blank, and I turn it flat,
yep,
and it's 12.3 millimeters. I should turn it to 12.
yeah, I do a little rounding off. I'm not going to lie to you there. You know, yeah, this thing will measure down to 0.99. I ain't going to go that fine. so, but for instance here, this is 72 millimeters. So to get 30% of that, 7.2 times 3 is 21.6. That's 22 millimeters to me. So if I reset my caliper to 22 millimeters, there,
Now you can do your ends.
that gives me my end. And if I mark off the 72 millimeters for the length of the piece, then I've got it. Because the center, I really don't care about it. It's those two end markings that are really critical, because those are the tangential markings. The centerpiece is only the remainders. It's only what's left over. So if I do 22 millimeters and 22 millimeters, I don't know what, I don't care what this is in between, but I've got my markings. And then the other thing that's really important is when you do one mistake that, you know, that a lot of us, that I was making, I was going to go back to set it up on the lathe here. Hmm? Yeah. Okay. We'll go ahead and I won't do a complete sphere on this, but I can set up and do the markings on it. You know, first of all, you want to make sure when you put your piece on, true it up first. And when you're truing it up, measure your diameter so you have the consistent diameter all the way along. You don't want any kind of, you know, variation in that, because that will affect your ability to get accurate tangential lines in here. So I'm going to crank it up. And the reason for the part that I did, the shallow part, was just so I had a point of reference to lay down the caliper. I could go from the end of the piece, but I can't see it down here. So to me, it makes more sense to do it like this. Yeah. Like so. And then I'll take Soren sphere. Okay, that gives me my my length, like so. And then if I were using these calipers, I would go in 22 degrees. Yeah, 22 millimeters, yeah. Oh, look at that. I don't know if you can see it or not, but it just happens that by doing the measurement with that, I come up with exactly where I need to be. And the other thing that some people, again, you know, I think are overly fixed on the absolute accuracy, getting it down. The pencil wears down. So the pencil lines are going to vary in width, and if you put these on a metric rule, you can actually measure the tip of the pencil. The pencil gets broader. So, you know, as long as you're close, and I'm not saying, you know, that you can just wing it. I think you do have to do some measurement. But to me, it makes a lot more sense to do it this way than trying to sit down and do calculations like this. Because when I first started this, I thought this was the way to go. You'll notice that this is laminated. There's a reason why it's laminated. I couldn't find them. I also had grease pencils that went with these, and I did a whole bunch of these. And the idea was to do the measurements using, you know, the sample here, and then take the grease pencil and write in the product here. That's a lot more bookwork than I want to do. You know, I had to do stuff like this, you know, when I was still working. But after I retired, I gave up on doing things like this. And, you know, I don't know why I even kept this one. I think I threw the rest of them away. This was April of 2019. Remember, Kelly? So.
You got 3 lines on there.
Yep.
30, 30.
30, 40, 30. So now I'm going to do a part here. And then I take my little calipers, and this is where the center portion does come into to play. I'm going to measure that center portion just with the calipers, just, you know, to set a caliber diameter, and then I'm going to turn down the tenon on both sides here to this diameter. Yes, right. And the result of that is that when I get this turned down, I'll have the 30 down from the corner down, and then the 40 across, and then 30 again on the other side. It's a little bit deceiving too when you look at it. The diameter of this and the length that I've got between the parts, they're the same. It doesn't look that way. It is a little bit of an optical illusion, I think. Yeah, when you get it round, then all of a sudden, yeah, it'll make sense.
And you use just a parting tool and the negative.
Well, I use a spindle gouge too. Yeah. Yeah, actually, when I rough them, you know, that's, yeah, that's.
You use the spindle gouge for your flats.
Yeah, oh yeah. And I brought 2 spindle gouges today. I was using a 1/2-inch Thompson, which is kind of my favorite. I like this one, but for smaller work, and it's not technically it's not a detail gouge, but I also have a 3/8 inch. This is a Hamlet, which I can't remember which one of the British tool manufacturers makes these, but this is from Craft Supplies. I've had this for years, and this tool does come in handy for doing a lot of detail work. It's got a little bit deeper flute than most detail gouges have. I have a Thompson detail gouge, and I've had trouble with it. It has such a shallow flute. I don't know why, but I get skating problems with it. I need to practice that. I need to work on it one of these days. But anybody else? Yeah.
Style points for putting your blank together
Yeah.
and how it looks, whether it's solid wood versus a glue up.
Yeah. This is construction grade lumber, done out of a 2x12. And I did a whole bunch of these. I had one of these crates full of them for practice pieces because, you know, I forget what this is, but this is a piece of wood that's actually a pretty nice piece of wood. Yeah, and I didn't want to trash a whole bunch of them, so I did a whole bunch of spheres using this stuff. And the key to it is that you make sure that you flatten it. So I either ran it through my planer or the drum sander, you know, to get flat surfaces. I use Type Bond 1 to laminate them together, and don't hurry them. And they make pretty decent turning blanks, but this one is actually kind of hard to even find the glue joint. Yeah, there's the glue joint right there. I can see it, but.